Welcome, Calculus AB. This is lesson 4.2, increasing and decreasing functions, and the first derivative test. Let's begin. So, going back to this function. Where is this function increasing and decreasing? So that means like increasing is a positive slope and decreasing is a negative slope. So if I'm following from left to right, we can see it's increasing along this path until it gets up to here. And then we're going to be decreasing as it goes down this path until it gets down to here. And then we're going to be increasing again. So that's how this function works. Increasing, decreasing, increasing. It's like kind of like if you're going up or down a hill. So where are the critical numbers? Now another thing is critical numbers happen at wherever you have like the relative maxes and mins. So a critical number happens right here, the top, the vertex here, and the vertex down here. Notice things like the critical numbers are where it changes from increasing to decreasing and from decreasing to increasing. And that's one of the things about critical numbers. They're kind of like they set the intervals where you could change if you go from increasing to decreasing. And here's what that looks like. That means that we have, since they're critical numbers, that one way to determine if something is a relative min or max is by determining what the slope is of the function. So relative mins happen when you do something like this, right? And the relative minimum would be down here. It's when you go from decreasing to increasing. So your derivative f prime is going to be negative on the left, and f prime is going to be positive on the right. So that would make it minimum. Now, a relative max can look like something like this. So the maximum's like right up here. And this happens when you start increasing and then you go to decreasing on the right. So f prime on the left equals positive and f prime on the right is negative. This is important. Now, you have also other cases with critical numbers that might do something like this. And where you have a critical number there, or you have something like this and a critical number here. Now, in both these cases, I'm increasing. In this case, I'm increasing on the left and increasing on the right. So this, although it's a critical number, it could end up this way. Sometimes it's not a relative min or max. So we say it's not a relative min or max. In this case, we're decreasing on both sides as well. This is not a relative min or max. It's just kind of, they're both decreasing. This can happen. So, you got to check the left and right to see if you're going to have a relative min or a relative max. And so this is what we use. We call like the first derivative test. So sometimes I want to know when is a function increasing or decreasing. And that means like on which interval. So it might happen on an interval like from 0 to 5 or something like that. It's increasing. And then from 5 to 7, it's decreasing, whatever. So how do we do this? One thing to remember is increasing and decreasing only change at the critical numbers. So I have to find the critical numbers first. So the first step is to figure out the critical numbers. Remember, that's when the derivative equals 0 or does not exist. And then you want to test you want to test those set your intervals, and you want to test values in between those critical numbers and then on the outside edges too. And you only have to test in between the intervals. And if one point in that interval, like the derivative of that point is positive, then you know that interval is increasing. And if the derivative of that is negative, it's decreasing. Those intervals will all either be increasing or all decreasing. They only change, as we saw in the last examples, at critical numbers. So you only have to check in between critical numbers. So test the values and you figure out where it's increasing or decreasing based off of the first derivative, if it's positive or negative. Now, and then you might be asked, well, where are the relative minimums and maximums? So the third step to this is to use where you found the negative and positive to figure out if it's relative min or max. Remember, it's relative min if you go from decreasing to increasing, and it's relative max if you go from increasing to decreasing. All right, so let's see what this looks like as an example. So where is this function increasing or decreasing? First thing I'm going to do is I'm going to graph this. So I want you to be able to see the function. So as I'm doing this, it's 2x squared minus 12x plus 15. All right, I'm sure the window's not going to be the right size, so we're just going to graph it. Let's see what it does. I'm sure I'm going to have to change the zoom. I don't think that's going to fit it at all. No, it didn't. So we're going to zoom. I'm going to go zoom fit and see what it does. So one way just to give you a good picture of it. So while that's going on, my first step, I have to figure out the critical number. So step number 1, I want to find the critical numbers. So I got to figure out what the derivative is. That didn't work either. What are you doing to me? So we should change the y maximum to like, I don't know, 30. And x min and max, sure, I hope that's better. Give me a parabola shape? No. I'm gonna go to, I don't know, 10? Maybe? Okay, you can kind of see it now. There you go, a little better. Okay, the critical numbers. So you gotta find f prime of x is 4x minus 12. So you're setting that equal to 0. And then add 12 to both sides. Divide by 4, your x equals 3. So my critical number is just x equals 3, and it's the only one. All right, now step number 2 is you find intervals of increasing and decreasing. And the way I want to do this, and this is how you should set it up, set up a little table thing. And each of my critical numbers is a spoke. So you say x equals 3 like this. And so you have domains on the left and right side. So I'm going to say the domain over here is going to be from negative infinity to 3. And the domain over here is going to be 3 to positive infinity. All right? So set up your tables like this. And then you want to pick a test value in between. So I'm going to pick a test value less than 3. It doesn't matter. I'm going to pick x equals, you can go negative 1,000,000, but let's just say 0. And bigger than 3, I'm just going to say x equals 10. I'm just like dealing with nice numbers like that, but you could have gone like 1. You could have gone like 4 over here, doesn't matter. And you're going to plug it into f prime. So I'm going to say f prime of 0 is going to be 4x minus 12 is going to be 4 times 0 minus 12, which is going to be negative 12, which is a negative number. All you care is negative or positive. This one I'm going to plug in 10, which is going to be 4 times 10 minus 12, which is 40 minus 12, which is 28, which is a positive number. So I know if this is negative, we are decreasing, and when it's positive, we are increasing. So I'll say it's increasing on the domain from negative infinity to 3, and it's decreasing on the domain from 3 to positive infinity. And that's what I want to do for my answer. There's a lot of work to that, but please set this up and just a lot of practice. All right, and that makes sense looking at my graph. You can see that it's decreasing on the left to about 3 and then increasing over here. All right, so I'll skip that example. Okay, so let's do this example. So I'm going to graph this. Well, maybe it takes a little longer. That's fine. You can skip ahead a little bit, double speed it. I don't care. I'll never know. As long as you watched it and got a view. That's all I care. All right, so while that's going, and I'm going to have to reset that window, you got to find your derivative. It's going to be 3x squared minus 6x, and I want to set that equal to 0. So your first step, okay, so you can kind of see it's like doing this thing, like this shape. Okay, so you can kind of see it. So you might even be able to say, okay, it's increasing here, and then it's decreasing, then it's increasing. All right, let's figure out what those points are. So I'm going to factor out a 3x, and I'm left with x minus 2. And so when you're solving, now you're in factored form. This one's going to get 3x equals 0, so x equals 0. This one's x minus 2 equals 0, so x equals 2. These are my two critical numbers. So the table's going to look differently now. Instead of having one little spoke thing, I'm going to have two. I'm going to have one at x equals 0 and at x equals 2. So your intervals, and these are good to label, especially for practice right now, are negative infinity for 0 to 0. This one's 0 to 2, and this one is 2 to infinity. And you pick test value points. So I'm going to pick, let's say, x equals negative 1. I don't want to do that in purple. So you're going to try y prime at negative 1. In this case, is going to be 3 times negative 1 squared minus 6 times negative 1, which is going to be 3 plus 6, which is 9, which is positive. 0 to 2, let's do the middle number, x equals 1. And so y prime is going to be 3 times 1 squared minus 6 times 1, which is 3 minus 6, which is negative 3, which is negative. And let's, you know what, let's try, I don't know, 1,000. Let's be weird. So y prime is going to be 3 times 1,000 squared minus 6 times 1,000. Oh, man. Bad call. Which is going to be 3 million minus 6,000. And you know what? That's going to be positive. Yeah. So I know I'm going to say I'm increasing. I'm just going to abbreviate now. When I'm on the interval negative infinity to 0 and from 2 to infinity. And I'm going to be decreasing on the interval from 0 to 2. There. Which makes sense looking at the graph. All right. I can do these two. There's a lot of videos already. Okay, relative extrema. So, great. Remember this thing? Let's do this example. I'm just going to pull this. Okay, so I want to find the relative extrema of this graph. So, remember this one? I found out where it's increasing and decreasing, but I want to figure out where the relative mins and maxes are. So, the last step to this is I know it's increasing, and then it's decreasing, and it's increasing again. Well, this x equals 0, if I'm going from increasing to decreasing, this is why I kind of like drawing these arrows, is clearly this is going to be a relative max at x equals 0. And then if I'm going decreasing to increasing, I clearly have a bottom here, and that's a relative minimum at x equals 2. So that's what I want to find. And I can find those as coordinates, but as long as you identify that, that's okay. All right. That's it. All right, we're done.